All right, friends and neighbors, welcome back. Today we are going through Chapter 19, IP addressing on hosts. Now, if we just did IP addressing on hosts, that would be kind of boring. So we're also going to add in a DHCP server build on a Cisco router and DHCP relay build on a Cisco router. It's actually just a couple of commands, so it'll be very straightforward, but it underscores all the concepts in the chapter, and the chapter actually covers helper addresses also. So in this video, I'll show you the list of key topics, the things that we're supposed to learn, and we've got the exam section. This is network fundamentals, verifying the IP parameters. So we'll show how to do that on a router, and we'll go over some of the ways to do that on hosts. And then, of course, we'll talk a little bit about DHCP and DNS, and then verify the DHCP client and the relay stuff. And then lastly, we'll do the did I or did you know this already questions. So it's a long list of things, but some of the key takeaways from this page, right? We've got some very special addresses that we're going to go over. I'll show you those in packet capture. A lot of stuff on the IP helper command or the IP helper address command, and then what that changes in a DHCP discover message or in the DHCP exchange. And then we'll talk about, especially when we get to the questions, what has to be true if you're going to get a relay agent to work. And so then we'll talk about some of the stuff that we see on hosts. Now, the dynamic host configuration protocol, this is a foundational topic. We have to know something about this. And the key here is that somewhere on your network, you've got some way to get IP addresses. It's completely impractical to have your host statically configured all over the place. So, of course, we have a DHCP server out there. Now, we will see that by default, if we don't change anything, right, then every network or every subnet has to have their own DHCP server. Now, I'll tell you why here in a second, and I will show you why later on. But the DHCP server's job primarily is to give you an IP address. But of course, an IP address is not enough. There are 4 magic numbers that you need to have to be operational on any network. You need an IP address, a mask, a gateway, or the router that you're going to use to get to the rest of the world, and a name server. Okay, so those are the 4 things that you need every single time. Now, the DHCP server can actually give out a lot more than that. There are all kinds of shares that you can add, all kinds of additional services or servers that are out there that can be added with a DHCP offer message. There are 2 flavors of addresses that we give out in a DHCP server. One is reservations. So if you get the same IP address every single time you connect to a network, it's probably because there's a reservation, and the reservation is based on your MAC address. So it's configured on the server. The server says, oh, I know this node's MAC address. This node is supposed to get this IP address. And it will never give that IP address out to other nodes. The other addresses are what we call free pools of addresses. So it's a list of addresses that you can give out to anybody. So if you are getting an address from the free pool and you connect, you'll get an address. If you leave and then connect again, you might get a completely different address. So these are not reserved. They have nothing to do with you in particular. Now, the nice thing about that is that it allows mobility, right? You can move all around, and it's very, very common for networks to have guest sets of addresses. And so it allows mobility between networks. It allows you to have events and have clients in there. So even your home network almost always has a wide range of addresses, and you don't set up reservations. So when folks come over to your place, right, they can get an address on your network. Now, one of the key ideas here, because of the addressing that's being used, every network or every subnet has to have a DHCP server. Now, that's not the way that we actually set it up, but if we didn't change anything, then they would all need to have their own DHCP server because we're using what we call local broadcast addressing. But the thing that allows us to go beyond that, the thing that allows us to have centralized control over our DHCP servers or put them in a central location to make life easier on management, is the DHCP-Relay. Now, DHCP-Relay is enabled on a Cisco router with the IP helper address command. and we'll do that in a demo. Now, the basic process that all hosts go through, and it doesn't matter what kind of node we're talking about, they all go through what we call the DHCP DORA process. And the initial part of it, you can see in the capture right over here to the side of me. The first thing that happens is that a host sends out a broadcast message. That's a DHCP discover. And the host is effectively yelling to the world, hey, I need help. I need an IP address. Now, these addresses are really, really important to realize. We'll cover them in detail later, but I'll just point out that the host is coming up with a 0.0.0.0 address. This is reserved for the DHCP process, and it's using a special broadcast that doesn't go beyond a router. Now, the DHCP server will see this request, right? Because it opens up all hosts will open up the broadcast, but there's a DHCP server that says, oh, this is a DHCP discover message. Let me respond with an offer. So this is from the server to the client. And then the client says, oh, I like this offer. I'm going to make a request. Can I please have that? And then the server will say, I'm going to acknowledge your request, and you can now use this from here on out. So I've showed you the directions, but it's basically client to server, server to client to server, and then server to client again. The numbers in parentheses here, the 1, 2, 3, and 5, those are just the number of the type of DHCP message. There's a couple of other ones. Now, after this process is completed, the host can use the address that was offered. But let's take a look at an actual capture. So here is where this process begins. There's the DHCP discover, and we can see a couple things here. We can see that we're using all zeros for the host source address. This is a reserved address for hosts in the DHCP process or in the boot P process if we go back a little bit. Here is the broadcast. Here it's a local broadcast, a broadcast on this network only. Now this is also tied to a layer 2 broadcast because layer 2 and layer 3 don't do anything in isolation from each other. And then we can see UDP encapsulated here, ports 68 and 67. And we can see that this is actually a DHCP discover message type 1. And we can see that there's really nothing filled in here. I just have placeholders. Please, somebody fill this in. Well, the server comes back, and if we take a look at the addressing here, this is back to broadcast. Because remember that the host at this point still doesn't have an address. We still haven't resolved this problem. This is just an offer from the server. So the server sends back a broadcast, and it goes back to the MAC address, but one of the things that's important here is that DHCP messages are tied together with an ID of some kind. So here's a transaction ID that puts all of these together. Now this isn't part of the chapter, I don't think it's on the exam, but this is how all of these messages are tied together. And you can see that the server has said, well, here, you can use this address now. Well, the host says, oh, I like what I'm seeing there. I'm actually going to request that. Yes, please, can I have that address? Again, it's not using anything that it says, but I'm going to say, can I have the address that you just offered me? And the server comes back and says, yes, you can use that one. And you can see right here, the client finally starts actually using that address. So that becomes important to us. Off here on the right-hand side, you can see all of the transaction IDs tying this together. So again, these special addresses, 0.0.0.0 is reserved for hosts that don't yet have an IP address. In other words, hosts in the DHCP process. This is not to be confused with the default gateway line. These are two different uses of this pattern. 255, 255, 255, 255 is a local broadcast. It's a broadcast on this network. It's not forwarded by routers. And this is why, by default, every single subnet or network would need its own DHCP server. But of course, we're going to turn on IP helpers. Now, every once in a while, you'll have a failure in the DHCP process. You will not get an address. And so you'll wind up with something that begins with 169.254. This is called an automatic private IP addressing, or a PIPA. It is covered by an RFC 3927, called Dynamic Configuration of IPv4 Link Local Addresses. Now, the actual range of addresses is 169.254.1.0 to 254.255. the first octet or the first 256 addresses and the last 256 addresses are already reserved. So the addresses come from in this. And you just randomly grab one of those, and then you ARP for that one to see if anybody has it. So these are what we use to enable IP communication if we don't have a DHCP server out there. So we still have the ability to communicate. We still can do some stuff on an IP network, but it's not likely that these are routed anywhere. Now, DHCP-Relay. You have a choice when it comes to configuring your DHCP servers. You could put one on every network, or you could locate your servers in a central location. This is what most organizations do. But when you think of an enterprise network, how many subnets or networks are we talking about? Dozens? Hundreds? And so it would be very, very challenging to manage putting servers everywhere. So it's very common that we have servers in a central location, or at least the management of those is centralized in some way. Now that means that we're going to configure a DHCP relay agent somewhere. Now Windows can act as a DHCP relay agent. Linux can act as a DHCP relay agent, but it's very common to turn your routers into a DHCP relay agent using, in this case, the IP helper address command. Now I will also say that routers will also, or can also act as DHCP servers, but we don't usually like to do that. I'm going to do that in the demo today because I don't have a server built into Packet Tracer. So I'm going to show you how to build that. We'll do that as part of our demo, but it's very, very common to have routers act as helpers. Now, the minute we have relay agents going, it changes the packets that we've seen to include the router's address in some of the fields that we see in DHCP packets. And I'll go over that here real quick as we do our demo. Now in this topology below, what we're looking at here is if I have a DHCP server sitting on this router right here, this 2811, PC0 is a DHCP client and it gets an address from our router. So we would see a DHCP exchange right here. Now we've got other hosts on the other side of a router, but there's no DHCP server on the right-hand side of this topology. So the question is, how would PC1 get its IP address? And the answer is that we would have to turn on DHCP relay in our middle router so that it could forward requests to this particular DHCP server. Let's take a quick look at our packets again, and then we'll do the demo. So when you're looking at capture, what's different if I have a relay agent in place? Well, if I'm capturing on the client side and the server is sitting in the same network that I am, the first thing is that I can capture everything between the client and server on one side or on one network. And the DHCP server address will be the same as any relay agent or anything else in there. But in this case, you can see that I actually have a relay agent identified and the server is actually somebody else. So we can see that this is one of the fundamental differences between acting as a relay agent and acting as the server all by yourself. So as we go down through the captures, right, we can see that we're using this consistent broadcast addressing. But another difference would be that if I was using a relay agent and I wanted to understand everything, that I can't just capture on the DHCP server side. I need to capture on both sides, where the client is, and then the relay agents exchange, and then where the server is, and the relay agents exchange between the server and itself. Lastly, some of this broadcast traffic that we're using will be converted to unicast traffic because the relay agent will communicate directly with the server. So on to our demo. Now I'll try to explain the steps as I go and make sure that we understand exactly what's going on. But the first thing that we'll do is we'll take a look at this host. Now this host is set up as a DHCP client, just like the router is. Usually in Packet Tracer we just use static configurations, but let's set this up to be a DHCP server and client situation. All right, so if you're on the router and you want to set up a DHCP server, now I've already set it up, but I'm going to do the steps anyway so that you can see. First, I'll show you the config. Do a show run here. And you can see that I have this pool of addresses. Now, in keeping with the idea that there are 4 main numbers that we need, right? IP address, mask, router or default gateway, and then our name server, we're going to make sure that we give out all of those to our host. So we'll make sure that we add whatever we're missing here. The other thing is that we're going to make sure that we tell the server, look, if there are special addresses that you don't want to give out, then we need a line or a config of some kind that says, don't give those out. Now, importantly, your DHCP server has to have an IP address on this particular network. So this is the 172.16.1 network, and I think that's the same as the one is in the book. And so my router has an address on that network. That's really important. And that's pretty much all there is to this config. So again, if I was going to work my way through it, I would say config T, and I would say IP DHCP pool, and I just called it the 16 net. Now, I know that my address, my interface right here is 172.16.1.254/24. So when I see what my options are for my DHCP server, I have to give out addresses that are on that network. So I would say network, well, what's the network? 172.16.1.0, and I'm going to give out addresses on that particular network. So that's the network. Now I don't have to specify the mask. So that's 2 out of 4, right? I've got the IP address and the mask, because the mask will come along with what I've specified right here. And now I'm going to say, well, my third one is the router. So you can see I've got a default router command. And as the default router, I'm going to use, well, let's see. Since this is just the server, I'll go ahead and specify that your default router is going to be 1.253. So that'll be right here so that we can communicate. I have to remember that we're not acting as a DHCP server here. So maybe what I'll do is make sure, because I configured this before, and I'll make sure that we're not going to give that other one out. So we'll do that. Okay. Now, the other thing that I need is a name server. So we need a DNS server. Now, I don't actually have one in this topology. Normally you would, right? But this is just a little packet tracer topology. So I'll go ahead and say that the router or my DHCP server is also my name server. Okay, now I could make something up, and maybe we will. Maybe we'll make something up. We'll say DNS server 8.8.8.8. Okay, so what we should be able to see is this in our packet transfers. So that is what we need to do to have our DHCP server running. And just to be complete, let's take a look at it. Oh, it got rid of, see, it's a good thing we looked. It got rid of my default router. So I'm going to go ahead and put that in there. The minute I did no default router, it got rid of it. So we're going to say default router 172.16.1.253. Now let's take another look. There we go. That looks a little bit better. We have our network. We have our default router, our DNS server. We've got this other pool that we haven't done anything with, and then we've got this excluded address. And the reason I added this, because I do not want to give out the address of the router to one of my hosts. So that's why that's there. All right, let's see the behavior of our host. And this also shows us one way to take a look at the host's IP address. So I can do this. I can say ipconfig, and this gives me some level of understanding. But this is old information. So what I might do is take some of the options here, and I might say release. Oops, maybe it doesn't like that. There we go. So we're releasing the information that we had, and I'm going to turn on the simulation now. And now we're going to say renew. And we can see right here, right, the client has said, I need to renew my information. Now, this will look a little bit different than DORA because a release and renew is different than the startup. But if I take a look at this, it's going to ask for its address to begin with. Let's see how Packet Tracer implements this. So we've got all of this zeroed out. So I got rid of the address that I had. Now, this host also doesn't have a reservation. It's working from the free pool of addresses. Okay, so it looks like the way they've got it set up in Packet Tracer, we're going to do a complete reconfiguration. All right, so let's see what happens next. This goes out to the switch. Now remember that if we look at, I guess I should have pointed this out. If we look at the addressing here, the source IP address is all zeros, and there's our broadcast. So the reason that the router finds this is because it goes out everywhere. So it goes blasted out everywhere. Our DHCP server opens this up and says, I got you. We got some ARP stuff to do. There we go. So this should be an offer that comes back. And again, we're still using our layer 2 broadcast, our layer 3 broadcasting back, but this will be back to the MAC address of the host. And what the server is saying is that I'm going to offer you this particular IP address if you like it. The client comes back and says, again, still using the broadcast addressing, but it says, you know, I'd like to go ahead and request this if I could. And we've got the server coming back now, and this should be straight up the acknowledgement that says after this point, you go ahead and use the one that you want, or use the one that's been offered. Okay, so at this point, we're done with DHCP. Now, if we take a look at our ipconfig commands, now this is actually part of troubleshooting. If I was having trouble with this host, or I just wanted to verify some things, I could do a simple ipconfig command, and I could see that I have an IP address, I've got the right mask, and I do have a default gateway here. If I do ipconfig/all, I can get more information, than I did before. There's my DNS. So these are all the things that I had in what's called my DHCP pool. And so this is some basic troubleshooting that I would use to test my host. And I can also test connectivity to my default gateway now. I can say, well, can I touch my default gateway? And I can. So life is good for this host. Now, while we're here, I just also wanted to point out that there's nothing at all that says that a router or some other network device can't be a DHCP client as well. If I do a show int f0/0, I think is the IP address, we can see that we're up, right? So we have link and the interface is not shut down, but we have no IP address here. If I don't want to configure an IP address, or this is an IP address on an interface that's connected to a service provider, what I might do is say interface f0/0 IP address, right? What are my options here? I might say, just give me a DHCP based address. Now, I don't think I was fast enough to do the simulation, but we can see right here that it pulled a .2 address from the DHCP server. So now if I say show int f0/0, I can see that I've got an IP address here, and that came from my DHCP server. In fact, a lot of times it'll actually say that this was a DHCP client. So that takes care of everything sort of on this side, right? If I sort of draw a line, that's everybody on the 192 or 172.16.1.0 network. But what about this host over here? It needs an IP address. Now for that, we need to configure the IP helper address because there's no server on the 2net. Let's take a look at this router's routing table. And we'll see one of the questions is, well, how do you know where your helper address ought to be? And the answer is that I need to know where the clients are, and I need to know that there's no DHCP server over here. So what I'm going to do is set up that helper address. Now on the IP helper address, we're not actually giving the address of the interface, we're giving the address of the DHCP server. So now we'll go ahead and we'll start the simulation again. And I'm going to go into this host's configuration. And I'm going to say, I want you to be a DHCP client. And we can see the minute I do that, right, there is this DHCP request that goes out. Now on this side, it is the standard DORA behavior that we're used to. But what's going to happen now is that the DHCP relay agent will see the request after all this ARP is done and forward it out to the server. There it goes. So now we can see on this side, right on the OneNet side, it's no longer broadcast. This is between these two IP addresses, the helper address and the router interface. So that is what's changed now. And so what we will also see is that now we've got this relay agent here that has an IP address that's different than the DHCP server. Now, the relay agent is working, but of course what we've forgotten to do is set up that other scope. So, good practice for us. Let's do that. And I'm going to say config T, IP DHCP pool, the 16.2 net. Well, what's the network there? Well, it's 172.16.2.0, 255.255.255.0. Well, we need a default router, 172.16.2.254, I think, is where it is. And then we'll do DNS 8.8.8.8 again. Now, the other thing that we'll now do is, because we don't want to give out the address of the router, I'm going to say IPDHCP excluded address 172.16.2.254. Okay. We take a look at our running config real quick. Now we have two scopes. They look very, very similar. We've added our excluded address. Now, one fun question is, how does the server know which network address to give out to a client? And the answer is, what is the IP address of the helper address that we see in DHCP? And once it sees that, it goes, oh, you're coming to me from the 2net, I'll give you an address over here. Well, let's see what's going on here. Now the host sends out this DHCP request. It goes out from the relay agent and goes up to the server, and there's our DHCP address coming back. Now, if I take a look at my host, right, initially, with no DHCP server, before we configured the pool, we got this 169, or an APIPA address. The nice thing now that we've got this, let's go back to real time. If we take a look at this now, oops, we're not on a router. If I do an IP config here, we now have an address on the 2net. And there we go. That is DHCP-Relay. Now, every once in a while, I suppose I'll show you two other things. Every once in a while, you need to help a router figure out where the other networks are. So that's what this command is there for. Right? Where is the 2net? Where are the hosts that I'm serving up? So be wary of that. And the last thing that I'll show you here is also one of the questions. If I do a show IP route, take a look what we have right here. We now have not only an IP address given to us by the DHCP server, but we have a default route. And that is because the DHCP server gave me a default route or a default router that I configured into a default route. Well, now I've got these two clients on either side of this router. A real test would be whether or not I can ping between them. And there we go. Everything works. So I built 2 pools, 2 sets of clients, and an IP helper address serving as the DHCP relay. So those important host details we know now are the IP address, the mask, the gateway, and your name server. With these 4 numbers, you can get anything done. You don't need anything else really to be fully functional on a network. Every once in a while, there are organization-specific servers that you need, but this gets us through most of our networking. If you're missing any of these, you're severely restricted in what you can do, if anything. Make sure that your mask that you're giving out in DHCP matches what the router thinks its mask is. And this is because the routing of packets is entirely based on the mask. If the routers and the host disagree, then the router may or may not be willing to forward packets for those hosts because of the address space that is controlled by the mask. Now, in a particular host, it's highly dependent on what operating system you're using. So if you're in Linux, you might use IPA or ifconfig. The operating systems each have their own tools. Some things are cross-platform, like netstat. Netstat is a very handy tool, and there are a bunch of examples in the book, netstat-r, netstat-rn. Netshow on your interfaces will also give you a command line based output. Now, your troubleshooting thoughts. We did a little bit about that in your hosts. So if your hosts are getting IP addresses, then your DHCP server appears to be communicating. But of course, if they're not, then you got to go to those packets. What is happening on the network between your clients and the DHCP server? Have you accidentally put a helper address pointing to the wrong place? And have you misconfigured your DHCP server itself? All right, our Did You Know This Already quiz. Question number 1. A PC connects to a LAN and uses DHCP lease on an address for the first time. Of the usual 4 DHCP messages that flow between the PC and the server, which ones do the client send? Well, we know that right off the bat. It's the discover and then the request after the server comes up with an offer. Question number 2, which of the following kinds of information are part of a DHCP server configuration? Well, we just configured that, so we know that we're going to give out the network or the IP addresses to lease, and then also the addresses not to lease. These are the excluded addresses. Question number 3, which answers list a criterion for choosing which router interfaces need to be configured as a DHCP relay agent? Well, we have to make sure that the subnet off of the interface has DHCP clients, but there isn't a server there. So that was A and C. Question number 4, a router connects to an internet service provider using its gigabit interface. With the IP address DHCP command configured, what does the router do with the DHCP learn default gateway? Well, we just saw that it adds a default route. In the following excerpt from a command on a Macintosh computer, which of the following parts of the output represent information learned from a DHCP server? Well, if we think about what we just configured and we think about the basics, we know that we need the IP address and the mask will have come from the server. All of this other stuff is interface specific or automatically figured out. Question number 6, which of the following commands on a Windows OS would list both the host IP address and DNS server's IP addresses as learned with DHCP? We saw that was ipconfig/all. Well, the chapter 20 look ahead, troubleshooting IPv4 routing. We're going to break stuff, so I'll do some examples where things don't work and then we'll fix it. So this is real test of connectivity and tools, all kinds of those static routes and directly connected routes that we're going to remind ourselves about. Now, we really have to get a handle on this because what's coming up in the next couple of chapters after 20, so 21, 22, 23, I think, are all going to be about OSPF, getting to know and love this ubiquitous routing protocol. So this has been chapter 19, IP addressing on hosts, but of course we know that we did a lot more than just IP addressing on hosts. The big 4 things that we get from a DHCP server: IP address, mask, gateway, and DNS. We also took a quick look at how DHCP works with the DORA process, but also how Relay works, and we configured both of those on Cisco routers. Well, like and subscribe if you're ready for some IP route troubleshooting. May those packets always reach their destinations, whether or not you're getting your IP address from a DHCP server or because you got help from a relay agent. And remember, this is CCNA. It's challenging, but you can do this.